Hi, my name is Caden Slovacek, and in this video, I'm going to be deriving an equation to find the coefficient of restitution between any object and the ground using only a ruler. To test the equation that I make, I'm going to go up to the gym in my apartment complex and find the coefficient of restitution between one of the medicine balls there and the ground, which is carpet. I'm going to go ahead and start by playing the clip. This problem is based off of the principle of linear impulse and momentum. The ball is initially traveling downwards with its initial momentum. Then, the floor acts on it with a normal force, which supplies impulse in the upwards direction. This causes the ball to have a final momentum in the upwards direction. We are interested in the coefficient of restitution, and that relies only upon the velocity entering impact and the velocity exiting impact. This means that we will not actually have to calculate the momentum or the impulse, but that is still the principle of the problem. To do this, we will be working under the assumption that the ground is rigid and stationary, that the medicine ball can be modeled as a particle, and that the only force acting on the ball is gravity when it is not in contact with the ground. Since we are only interested in the velocities entering and exiting the impact, we are able to use only a ruler and basic kinematics to find the coefficient of restitution. On the right, you can see that we've derived an equation that shows that the coefficient of restitution is equal to the square root of the final height over the initial height. For this medicine ball, the final height came out to be exactly 1/2 of the initial height, so the coefficient of restitution is the square root of 1/2, which is around 0.7071. We can take this one step further and say that the final height will always be 1/2 of the initial height for this specific medicine ball. The initial drop was at 6 feet, so we can check this out by trying a few different heights next to the ruler. Each one of the tape marks is 1 foot. The first drop I do to test the equation will start with an initial height of 5 feet. Using the equation, I will predict that the final height will be about 2.5 feet. 1/2 of 5 feet. Just as we predicted, the ball is at about 2.5 feet, which is 1/2 of the initial 5 feet. I thought it would be best to do one final drop to test that our equation is correct. This one will be starting with an initial height of 4 feet. And just as you would expect, the final height is 2 feet for this drop. It worked out nicely that the medicine ball always bounced back exactly half of the height that I dropped it at. But we found an equation that can always find the coefficient of restitution for any object, even if that's not the case. So get out your rulers and start dropping some objects. Bye.